Hello students, welcome to this lecture on binomial theorem. We will cover in this lecture NCERT miscellaneous exercise question number 1 to 6. This is disclaimer. So we will cover in this lecture NCERT miscellaneous exercise question number 1 to 6. So let's get started. Look at question number 1. Our question is if A and B are distinct integers, then we have to prove that a minus b is a factor of a to the power n minus b to the power n. Okay, whenever n is a positive integer. So here we have given hint. So here you can write a to the power n as a minus b plus b to the power n and expand using binomial theorem. So first of all, think about this question. How would you solve this question? Okay. Now let's see how to solve this question. So we will solve this question step by step. So we need to prove that a minus b is a factor of a to the power n minus b to the power n. So to prove this, we need to show that a to the power n minus b to the power n can be expressed as k times a minus b, where k is some natural number. Now let's consider the scenario where a and b are real numbers and n is a positive integer. Then according to the binomial theorem, we have Pn such that a plus b whole to the power n is equal to n choose 0 a to the power n plus n choose 1 a to the power n minus 1 times b plus plus n choose n b to the power n. We can also express the expansion using summation notation. Okay, so a plus b whole to the power n, this can be written as sum from k to k equal to 0 to n choose k a to the power n minus k times b to the power k for n belongs in natural number. Here NCR represents the binomial coefficient calculated as n factorial upon r factorial times n minus r factorial for 0 less than equal to r less than equal to n, and n factorial is equal to n times n minus 1 times 3 into 2 into 1. That means the n factorial is basically the product of all positive integers up to n. Okay. To connect this back to our original problem, so notice that a can be written as a minus b plus b. Okay. We put here x equal to a minus b and y equal to b. Then we get a minus b plus b whole to the power n. This is equal to a minus b plus b whole to the power n. Okay, and this is simply equal to a to the power n. Now we expand a minus b plus b whole to the power n by using binomial theorem. So this gives us a series of terms. n choose 0 a minus b whole to the power n plus n choose 1 a minus b whole to the power n minus 1 times b plus plus n choose n minus 1 a minus b times b to the power n minus 1 plus n choose n times b to the power n. Now continuing with the expansion, we can express a minus b plus b whole to the power n. This is equal to a minus b whole to the power n plus n choose 1 a minus b whole to the power n minus 1 times b plus dot 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 plus n choose n minus 1 times a minus b times b to the power n minus 1 plus b to the power n. From a to the power n, okay, a minus b plus b whole to the power n, this is equal to a minus b plus b whole to the power n, this is equal to a to the power n. Okay, so it implies a to the power n minus b to the power n, this is equal to a minus b times a minus b whole to the power n minus 1 plus n choose 1 a minus b whole to the power n minus 2 times b plus dot 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 plus n choose n minus 1 times b to the power n minus 1. So now we conclude that a to the power n minus b to the power n equals to k times a minus b, where k is the expression in the brackets. Okay, so here k is the some natural number. Okay, so this confirms that a minus b is a factor of a to the power n minus b to the power n, and we have expressed the difference as a multiple of a minus b. So where k can be expressed as a minus b whole to the power n minus 1 plus n choose 1 a minus b whole to the power n minus 2 times b plus dot 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 plus n choose n minus 1 b times b to the power n minus 1 is a natural number. And this shows that a minus b is a factor of a to the power n minus b to the power n for any positive integer. So I hope this question is clear to all of you. So now let's move to the next question. Now look at question number 2. So in this question we have to evaluate the expression square root 3 plus square root 2 whole to the power 6 minus square root 3 minus square root 2 whole to the power 6. Okay, so for evaluating this we will use binomial theorem. Okay, so first of all try it yourself. How would you approach this question? The question we are asking is how to evaluate the expression square root 3 plus square root 2 whole to the power 6 minus square root 3 minus square root 2 whole to the power 6. We need to evaluate root 3 plus root 2 whole to the power 6 minus root 3 minus root 2 whole to the power 6. To solve this, we need to recall a key principle of the binomial theorem. So if a and b are real numbers and n is a positive integer, then we can expand a plus b whole to the power n using a specific formula. Okay, so that we will see that now. So Pn such that a plus b whole to the power n, this is equal to n choose 0 a to the power n plus n choose 1 a to the power n minus 1 times b plus dot 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 plus n choose n b to the power n, where NCR is calculated as n factorial often r factorial times n minus r factorial for 0 less than equal to r less than equal to n. Now replacing b by minus b in a plus b whole to the power n, then we get Pn such that a plus minus b whole to the power n, this is equal to n choose 0 a to the power n plus n choose 1 e to the power n minus 1 times minus b plus dot 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 plus n choose n minus b whole to the power n. Using binomial theorem, the expression a plus b whole to the power 6 and a minus b whole to the power 6 can be expanded as a plus b whole to the power 6, this is equal to 6c0 a to the power 6 plus 6 1 a to the power 5 times b plus dot 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 plus 6c6 b to the power 6. and a minus b whole to the power 6, this is equal to 6c0. Okay, this is first term. Then minus 6 with 1 a to the 5 times b, this is second term. Okay, and the last term will be 6c6 b to the power 6. And now let's find the difference between these two expressions. So a plus b whole to the power 6 minus a minus b whole to the power 6, this is equal to 6c0 a to the power 6 plus 6c1 a to the power 5 times b plus 6c2 a to the power 4 times b square plus 6c3 a cube into b cube plus 6c4 a square into b to the power 4 plus 6c5 a into b to the power 5 plus 6c6 b to the power 6 minus 6c0 a to the 6 minus 6c1 a to the 5 into b, and other terms here, and the last term will be plus 6c6 b to the 6. For n equal to 6 and r equal to 1, then 6 with 1 is 6 factorial upon 1 factorial times 6 minus 1 factorial, this is equal to 6. And for r equal to 3, 6c3 equal to basically 6 factorial upon 3 factorial times 6 minus 3 factorial, this is equal to 20. And for r equal to 5, 65 is 6 factorial upon 5 factorial times 6 minus 5 factorial, this is equal to 6. Now put these values in the binomial expression, then we get a plus b whole to the power 6 minus a minus b whole to the power 6, this is equal to 2 times 6c1 a to the power 5 times b plus 6c3 a cube into b cube plus 6c5 into a to the power 5 into b, and this is equal to simply 2 times 6 times a to the power 5 into b plus 20 times a cube into b cube plus 6 times a into b cube, b to the 5. Okay, so notice how each term is multiplied by its respective coefficient. So simplifying further, we get a plus b whole to the power 6 minus a minus b whole to the power 6. This is equal to 4ab times 3 a to the power 4 plus 10 times a square b square plus 3 into b to the power 4. Now by putting a equal to root 3 and b equal to root 2, then we obtain root 3 plus root 2 whole to the power 6 minus root 3 minus root 2 whole to the power 6. This is equal to 4 times 3 times root 3 into root 2 multiplied with root 3 whole to the power 4 plus 10 times root 2 to the power 3 into root 3 whole cube plus 3 into root 2 whole to the power 4. Simplifying further, we get root 3 plus root 2 whole to the power 6 minus root 3 minus root 2 whole to the power 6. This is equal to 4 times root 3 into root 2 times 3 into 9 plus 10 into 3 into 2 plus 3 into 4. Okay, and further if you simplify, then you will get this is equal to 4 times root 6 into 27 plus 60 plus 12. Finally, multiplying the terms, we get square root 3 plus root 2 whole to the power 6 minus square root 3 minus square root 2 whole to the power 6. This is equal to square root of 6 times 396. Hence, root 3 plus root 2 whole to the power 6 minus root 3 minus root 2 whole to the power 6. This is equal to 396 times root 6. So I hope this question is clear to all of you. So now let's move to the next question. In this question, we have to find the value of a square plus root a square minus 1 whole to the power 4 plus a square minus root a square minus 1 whole to the power 4. So first of all, try it yourself. So our goal is to find the value of a square plus root a square minus 1 whole to the power 4 plus a square minus square root of a square minus 1 whole to the power 4. So we need to find a square plus root a square minus 1 whole to the power 4 plus a square minus root a square minus 1 whole to the power 4. If x and y are real numbers and n is a positive integer, then Pn such that x plus y whole to the power n is equal to n choose 0 x to the power n plus n choose 1 x to the power n minus 1 times y plus dot 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 plus n choose n y to the power n. So where nc r equal to n factorial upon r factorial times n minus r factorial for 0 less than equal to r less than equal to n. Now replacing y by minus y in x plus y whole to the power n, then we get x plus minus y whole to the power n, this is n choose 0, x to the power n plus n choose 1, x to the power n minus 1 times minus y plus dot 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 plus n choose n minus y to the power n. So in Pn, such that x plus y whole to the power n, this is equal to n choose 0, x to the power n plus n choose 1, x to the power n minus 1 times y plus dot 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 plus ncn y to the power n. We put the value of n equal to 4. Then we get the expression x plus y whole to the power 4 plus minus, so plus x minus 4 y whole to the 4. Okay, and is simplified by using the binomial theorem. So x plus y whole to the power 4, this is equal to 4c0 x to the power 4 plus 4c1 x to the power x cube times y, and the other terms here, and the last term will be 4c4 y to the power 4. For n equal to 4, r equal to 0, then 4c0 is 4 factorial upon 0 factorial times 4 minus 0 factorial, and this is simply equal to 1. And for r equal to 1, 4c1 is 4 factorial upon 1 factorial times 4 minus 1 factorial, this is equal to 4. For r equal to 2, 4c2 is 6. And similarly, we can find the value of 4c3 and 4c4. So now let's summarize the coefficients we have found. 4c0 is 1, okay, and 4c4 4c okay 4c1 is 4, 4c2 is 6, 4c3 is 4, and 4c4 is 1. So put these values in the expansion x plus y whole to the power 4, then we get x plus y whole to the power 4, this is equal to x to the power 4 plus 4 times x cube times y plus 6 times x square into y square plus 4 times x into y cube plus y to the power 4. So in Pn, so the x plus minus y whole to the power n, this is equal to nc0 x to the power n plus nc1 x to the power n minus 1 times minus y plus dot 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 plus ncn minus y to the power n. So we put the value of n equal to 4, then we get x minus y whole to the power 4, this is equal to 4c0 x to the power 4 minus 4c1 x cube times y plus 4c2 x square into y square minus 4c3 x cube plus 4c4 y to the power 4. So after simplifying, we get x minus y whole to the power 4, this is equal to x to the power 4 minus 4 times x cube times y plus 6 times x square into y square minus 4 times x into y cube plus y to the power 4. So x plus y whole to the power 4 plus x minus y whole to the power 4, this is simply equal to 2 times x to the power 4 plus 6 into x square into y square plus y to the power 4. So in x plus y whole to the power 4 plus x minus y whole to the power 4, this is equal to 2 times x to the power 4 plus 6 times x square into y square plus y to the power 4. So putting here x equal to a square and y equal to square root of a square minus 1. Then we obtain a square plus square root of a square minus 1 whole to the power 4. This is plus a square minus square root of a square minus 1 whole to the power 4. This is equal to 2 times a square whole to the power 4 plus 6 times a square whole square into square root of a square minus 1 whole square plus square root of a square minus 1 whole to the 4. Okay, and next we simplify the expression further. Then a square plus square root of a square minus 1 whole to the 4 plus a square minus square root of a square minus 1 whole to the 4. This is simply equal to 2 times a to the power 8 plus 6 times a to the 4 times a square minus 1 plus a square minus 1 whole square. Okay, and further simplifying, we obtain this expression. This is equal to 2 times a to the power 8 plus 6 times a to the power 6 minus 6 times a to the power 4 plus a to the power 4 minus 2 times a square plus 1. Okay, and further simplifying, get this is equal to 2 times a to the power 8 plus 6 times a to the power 6 minus 5 times 4 a to the power 4 minus 2 times a square plus 1. Hence, a square plus square root of a square minus 1 plus whole to the 4 plus a square minus square root of a square minus 1 whole to the 4. This is equal to 2 times a to the power 8 plus 12 times a to the power 6 minus 10 times a to the power 4 minus 4 times a square plus 2. Now we will look at question number 4. So in this question we have to find an approximation of 0.99 whole to the 5 using the first 3 terms of its expansion. So our focus will be on finding an approximation for 0.99 whole to the 5. So we need to find an approximation of 0.99 whole to the 5 using the first 3 terms of its expansion. So if x and y are real numbers and n is a positive integer, then Pn such that x plus y whole to the power n, this is equal to n choose 0 x to the power n plus n choose 1 x to the power n minus 1 times y plus dot 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 plus n choose n y to the power n, where NCR is equal to n factorial upon r factorial times n minus r factorial for 0 less than equal to r less than equal to n. Now replacing y by minus y in x plus y whole to the power n, then we get x plus minus y whole to the power n, this is equal to nc0 x to the power n plus nc1 x to the power n minus 1 times minus y plus dot 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 plus ncn times minus y whole to the power n. So we can write 0.99 as 1 minus 0.01. Now value of x equal to 1 and y equal to 0.01, then using the binomial expansion, then we get 0.99 whole to the 5, this is equal to 1 minus 0.01 whole to the 5. So 1 minus 0.01 whole to the 5, this is equal to 5c0, 1 to the power 5 minus 5c1 on to the power 4 into 0.01 plus 5c2, 1 cube times 0.01 whole square. Then it implies 1 minus 0.01 whole to the 5, this is your 1 minus 5 into 0.01 plus 10 into 0.01 whole square. So if you further simplify, then you will get 1 minus 0.01 whole to the 5, this is equal to 1 minus 0.05 plus 0.001. So further simplifying, we have 1 minus 0.01 whole to the 5, this is equal to 1.001 minus 0.05. Hence 1 minus 0.01 whole to the 5, this is equal to 0.951. Thus the value of 0.995 whole to the 0.99 whole to the 5 is approximately 0.951. Now look at question number 5. In this question we have to expand 1 plus x by 2 minus 2yx whole to the 4, where x is not equal to 0. First of all, try it yourself. So let's solve this question step by step. So we need to expand 1 plus x by 2 minus 2 upon x whole to the 4, where x is not equal to 0 using the binomial theorem. So if x and y are real numbers and n is a positive integer, then x plus y whole to the power n, this is equal to nc0 x to the power n plus nc1 x to the power n minus 1 times y plus dot 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 plus ncn y to the power n. So where ncr is n factorial upon r factorial times n minus r factorial. Now replacing y by minus y in x plus y whole to the power n, then we get x plus y minus y whole to the power n, this is nc0 x to the power n plus nc1 x to the power n minus 1 times minus y plus dot 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 plus ncn minus y whole to the power n. Using binomial theorem, the given expression 1 plus x by 2 minus 2 upon x whole to the power 4 can be expanded as so here the value of a is equal to 1 plus x by 2 and b equal to 2yx. So now 1 plus x by 2 minus 2 upon x whole to the 4, this is equal to 4c0, 1 plus x by 2 whole to the 4 minus 4c1 1 plus x by 2 whole cube times 2yx plus 4c2 1 plus x by 2 whole square into 2yx whole square minus 4c3 1 plus x by 2 times 2 upon x whole cube plus 4c4 2 upon x whole to the 4. So next we substitute the values of a and b into the formula. This gives us and further simplify, you will get 1 plus x by 2 minus 2 upon x whole to the 4. This is equal to 1 plus x by 2 whole to the 4 minus 4 times 1 plus x by 2 whole cube times 2 by x plus 6 times 1 plus x square by 4 times 4 by x square minus 4 times 1 plus x by 2 times 8 by x cube plus 16 upon x to the 4. So let's simplify the expression further. Then we have 1 plus x by 2 minus 2 upon x whole to the 4. This is equal to 1 plus x by 4 x by 2 whole to the 4 minus 8 by x times 1 plus x by 2 whole cube plus 24 upon x square plus 24 upon x plus 6 minus 32 upon x cube minus 16 upon x square plus 16 upon x to the 4. So continuing with simplification, we arrive. So we will get this expression. Okay, here you can see. So again, by using binomial theorem, we obtain the value of a equal to 1 and b equal to x by 2. So 1 plus x by 2 whole to the 4, this is equal to 4c0, 1 to the 4 plus 4c1, 1 cube times x by 2 plus other terms, and the last term will be 4c4 x by 2 whole to the 4. So let's simplify this expression further. Then we have 1 plus x by 2 whole to the 4, this is equal to 1 plus 4 times x by 2 plus 6 times x square upon 4 plus 4 times x cube upon 8 plus x to the 4 upon 16. Okay, so now finally, after simplifying, we obtain 1 plus x by 2 whole to the 4. This is equal to 1 plus 2x plus 3x square upon 2 plus x cube upon 2 plus x to the 4 upon 16. So 1 plus x by 2 whole cube, this is equal to 3c0, 1 cube plus 3c1, 1 square x times x by 2 plus 3c2 times 1 times x by 2 whole square plus 3c3 x by 2 whole cube. So after simplifying, we obtain 1 plus x by 2 whole cube. This is equal to 1 plus 3x upon 2 plus 3x square upon 4 plus x cube by 8. Now combining the obtained expression, then we obtain 1 plus x by 2 minus 2 upon x whole to the 4. This is equal to 1 plus 2x plus 3x square by 2 plus x cube by 2 plus x to the 4 upon 16 minus 8 upon x times 1 plus 3x upon 2 plus 3x square over 4 plus x cube by 8 plus 8 upon x square, okay, plus 24 upon x plus 6 minus 32 upon x cube plus 16 upon x to the 4. Okay, and let's simplify the expression further. Then we combine like terms and simplify the coefficients to get 1 plus 2x plus 3 upon 2x square plus x cube by 2 plus x to the 4 upon 16 minus 8 by x minus 12 minus 2x minus 6x minus x square plus 8 by x square plus 24 upon x plus 6 minus 32 upon x cube plus 16 upon x to the 4. Finally, we obtain the expansion of the given expression 1 plus x by 2 minus 2 upon x whole to the 4. This is equal to 16 upon x plus 8 by x square minus 32 upon x cube plus 16 upon x to the 4 minus 4x plus x square by 2 plus x cube by 2 plus x to the 4 upon 16 minus 5. So I hope this expansion is clear to all of you. Now look at question number 6. So we have to find the expansion of the expression 3x square minus 2ax plus 3a square whole cube using the binomial theorem. So let's solve this question step by step. So we need to find the expansion of 3x square minus 2ax plus 3a square whole cube using binomial theorem. So if a and b are real numbers and n is a positive integer, then a plus b whole to the power n, this is equal to nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 plus ncn b to the power n, where ncr is n factorial upon r factorial times n minus r factorial for 0 less than equal to r less than equal to n. Using binomial theorem, the given expression 3x square minus 2ax plus 3a square whole cube can be expanded as 3x square minus 2x plus 3a square whole cube. This is equals 3c0, 3x square minus 2ax whole cube plus 3c1, 3x square minus 2ax whole square times 3a square plus 3c2, 3x square minus 2ax times 3a square whole square plus 3c3, 3a square whole cube. So let's simplify each term. Then we obtain 3x square minus 2ax whole cube plus 3 times 9x to the 4 minus 12ax cube plus 4 times a square x square times 3a square plus 3 times 3x square minus 2ax times 9 times a to the 4 plus 27 a to the 6. Continue the simplification. Then we have 3x square minus 2ax whole cube plus 81 a square x to the 4 minus 108 a cube into x cube plus 36 a to the 4 into x square plus 81 a to the 4 x square minus 54 a to the 5 into x plus 27 a to the 6. So further simplify this. Okay, so then you will get this expression. So again, by using binomial theorem, we obtain 3x square minus 2ax whole cube. This is equal to 3c0, 3x square whole cube minus 3c1, 3x square whole square times 2ax plus 3c2, 3x square times 2ax whole square minus 3c3, 2ax whole cube. Okay, and then simplify further. Then you will get this is equal to 27x to the 6 minus 3 times 9 times x to the 4 times 2ax plus 3 times 3x square times 4a square x square minus 8a cube x cube. Further simplify, then you will get 3x square minus 2ax whole cube. This is equal to 27x to the 6 minus 54ax to the 5 plus 36 a square x to the 4 minus 8a cube x cube. So from now 3x square minus 2ax plus 3a square whole cube expansion and 3x square minus 2ax whole cube expansion, then we obtain 3x square minus 2ax plus 3a square whole cube. This is equal to 27x to the 6 minus 54a times x to the 5 plus 36 a square x to the 4 minus 8a cube x cube plus 81 a square x to the 4 minus 108 a cube x cube plus 117 a to the 4 x square minus 54 a to the 5 times x plus 27 a to the 6. Finally, we obtain 3x square minus 2ax plus 3a square whole cube. This is equal to 27x to the 6 minus 54a x to the 5 plus 117 a square x to the 4 minus 116 a cube x cube plus 117 a to the 4 x square minus 54 a to the 5 into x plus 27 a to the power 6. Okay, so this is our final answer. So I hope this question is clear to all of you. So that's all for today's lecture, and thank you very much to all of you.